Okay, so moving on with the next bit of our continuous random variables. Alright, so we've done about the mean. So today we're looking at measures of spread. And so the first one of those measures of spread is the variance. And the variance is a measure of the deviation. Oops, that's not how you spell that. Deviation from the mean. Alright, so the way that we calculate the variance, and the variance is variance of x, which of course we know is the standard deviation squared, sigma squared, and it is, as before, the expectation value of x minus the mean squared. Okay, so in terms of continuous random variables, so the way that we would work that out is because, again, remember it's that area underneath that curve, so we're going from negative infinity to infinity. Alright, theoretically negative infinity to infinity, but as you already know, that depends on the upper and lower limits of the actual function. So x minus the mean squared times the function dx, and the function, of course, is your probability density function. And the mean, of course, we've worked that out. So the mean is the mean here. That's a number that we've worked out. That's our probability density function. We stick them in, and we would use our calculator to do that for us, more than likely. Okay, so what else have we got then? So alternatively, of course, because the expectation value of x minus the mean squared is also equivalent to the expectation value of x squared minus the mean squared. Alright, again, we've learnt that before from when we did discrete random variables. Okay, so there's similarities, but they're not precisely the same, of course. So there's similarities in that. Alright, so the expectation value of x squared minus the mean squared, so the expectation value of x squared is the integral from negative infinity to infinity of x squared f of x dx, and of course we've got to take our mean squared away from that. Alright, so just also a reminder, standard deviation is another measure of spread, and the standard deviation SDX is equal to lowercase sigma, which of course is the square root of the variance of x. Alright, so let's have a look at an example or two of things. So first of all, just an example of calculating variance. Okay, so here it says, find the variance of the random variable with PDF, probability density function, fx, which is 0.5x, when x is between less than or equal to 0, x is greater than or equal to 0, less than or equal to 2. and every other x value it's equal to 0. So what we know then is that the variance of x is equal to the expectation value of x squared minus the mean squared. That's generally the easier way to work it out. Now, the mean is the expectation value of x, and so that's the integral in this case. Because we're between 0 and 2, our limits then are 0 and 2 of x times the function, and the function, there it is, 0.5x dx. And if we whack that in our calculator, you get 1.33. Right, the other bit that we need, so that's our mean there. The other bit we need is our expectation value of x squared. So to get that, the expectation value of x squared is the integral, and the limits are 0 and 2, of x squared times the probability density function, which is 0.5x dx. And when you do that, you get 2 on your calculator. So the variance of x, a reminder of that, was the expectation value of x squared minus the mean squared. So that's 2 minus 1.33 squared, which we would do on our calculator, and then we get 0.2231 for that. Alright, so there's our variance. Standard deviation, if you wanted it, you'd take the square root of that, of course. Alright, so remember, with this continuous stuff, we're using those integrals because we're looking at the area underneath that curve. Alright, there's another measure of spread that is used, and that's a thing called the interquartile range, commonly known as the IQR. So what's interesting about the interquartile range is it has the, let me get rid of that, has the middle 50% of the data is in that. So what it actually is the difference between the 25th, commonly known as Q1, quartile 1, and 75th, commonly known as Q3, quartile 3, percentiles. So what does that mean? The 25th percentile means that 25% of the data is less than it, and the 75th, 75% of the data is less than that. Alright, so as I said, it represents the middle 50%, and so that's quite interesting. Alright, so how do we find the IQR? So let's have a look at an example that explains that. Alright, here's our example. Alright, so here we've got a nice little probability density function, and it's 2x when x is between 0 and 1, or equal to those. 0 is less than or equal to, x is less than or equal to 1, and everywhere else it's 0. So the 25th percentile, let's have a look at the 25th percentile. So the 25th percentile. Okay, so when we look at our probability density function, it starts at 0, and it's 2x dx, and because we're after the 25th percentile in decimals, that's 0.25. So we want 0.25 of the data to be between there and some number, and that number we're going to call A. Alright, now this is a relatively simple one, so I'll do this one by hand. So the antiderivative of 2x, so this would be something like, you could get on exam 1, this one, where you can do it by hand. 2x anti-differentiates x squared between 0 and A, and that's got to be 0.25. So we get A squared minus 0 squared is 0.25, and so A squared is 0.25, and if I come up over here, that then means that A is equal to 0.5, and now we would normally go plus or minus, but when we have a look here, our x values have got to be between 0 and 1, so because our x has got to be between 0 and 1, that means A, which is the x value where the 25th percentile is 0.5. Alright, so there's our 25th percentile. Now let's go on to our 75th percentile. Of course, that's 0.75. So now we're going from 0 again to some number represented by B. I haven't used A because it's a different place, of 2x dx, and that's equal to 0.75. Again, this is an easy one, so we'll anti-differentiate it by hand from B to 0 is 0.75. So B squared minus 0 squared is 0.75. So B squared is 0.75. Then when we square root that, B is 0.8660. Again, for the same reason as before, remember B is the X value. We're 75% of the data, and we're between 0 and 1, so it's got to be plus, not. Alright, since 0 is less than or equal to X less than or equal to 1. Alright, so our interquartile range then is our 75th, so Q3, minus our 25th, which is Q1, which is 0.8660 minus 0.5, and that equals 0.3660 for our interquartile range. Alright, so that's it for our measures of spread. So exercise 15C questions on our work plan. Okay, so short lesson today, and then you've got probably, I would guess, plenty of stuff to keep you going. And of course, don't forget to like and subscribe and share with your friends.